So my name is Logan Saether. I'm from Chronologic. I'm a smart contract engineer. I'll be giving a talk about scheduling on Ethereum, why that's a problem, and how we're going about solving it. So first I'll talk about why scheduling is a problem on Ethereum. So it's not a foundational feature in Ethereum to be able to set a transaction that will be executed at a later time. Every transaction, when you sign the transaction and submit it, it goes into the transaction pool and it's executed as soon as possible. So there's no way to set a deferred execution or a delayed execution on a protocol level. But there's a ton of use cases for scheduling. Scheduling is something that people are used to. It's something that, at least when I first started developing with Ethereum, I ran into wanting to do it a lot. And a lot of people I've talked to have asked me about it. And almost everybody has, at one point or another, needed a way to schedule a transaction. So some of the use cases of this are like true smart contract automation. So being able to have contracts that can schedule other contract calls that will set off other contract calls more or less indefinitely, as long as these contracts are funded. Of course, things like ICOs, depending on time zones, people have to stay up really late at night or early in the morning. It would be a lot easier if we could just schedule those transactions to go through when the ICO opens. We have things like the ENS, which has a two-phase kind of system where you first commit and then you reveal that commit. So using a scheduler, you could have both those transactions set at the same time, so you don't have to remember to come back 2 days later. And then there's things like recurring payments. So it's actually a ERC right now, ERC 948, about reoccurring payment standard. For that, a scheduler could be really useful. And so the way that scheduling has been solved up until now has been server side. So a lot of people have set up client side, like cron jobs, that will send these transactions out at a specific time. The problem with that is that these client-side scripts, if they fail, then your transaction doesn't go through. But then, so like what if you have more than one server set up? You have two servers, the chances of two going down is less likely, but it's possible. So the optimal solution for this would to have a lot of servers that would be watching for an execution. And this is kind of the idea behind what we've been working on, which is the Ethereum alarm clock. So it's a decentralized execution server, basically. And I'll go into a little bit more about what that means. So the Ethereum alarm clock project is an open source project started by Piper Merriam. It was started in 2015, so it was one of the first large-scale dApps built on Ethereum. But it's ever since the 2016 DOS attacks, it's been non-functional. Piper has been getting involved in other projects, and his bandwidth isn't enough to continue the alarm clock project, so it sat non-functional for a while. Until Chronologic came around in late 2017, and seeing the gap in this functionality, decided to pick it up and to start it up again. So here's kind of a diagram of the alarm clock internals. This isn't the most up to date. We've kind of pruned this down a little bit. working on getting the latest version. But in a nutshell, the way it works is it's a smart contract protocol. So when a user wants to schedule a transaction, they send the parameters to a smart contract, which will deploy a new smart contract with these parameters in storage. And then we have a lot of servers, basically, which we're calling time nodes. And these are free to, they're free to anyone to run one of these time nodes. So the idea is that instead of running your own personal execution script on your server, if you run one of these, you contribute to the community of executions. And also, these time nodes are incentivized because when a transaction is scheduled, the scheduler will put a little bit of Ether in as a bounty, so they can get a guarantee that a time node will indeed execute the transaction. So the benefits of this is everything is verified on chain. So if you set the parameters, you know that there's no other transaction that will be executed instead. If the transaction is executed, it'll be executed exactly how it was set to be executed. And so we've been developing this ecosystem around the alarm clock. Right now on the Koban testnet, we've built JavaScript libraries to interact with them. We've been working on the smart contracts themselves toward a 1.0 release. And we have the contracts in the middle of a security audit at the moment. We've also integrated this into the MyCrypto beta. So what it is on the MyCrypto send transaction page, there's a switch that you can hit that says send later, and it uses the alarm clock on the back end. And you can just set the time that you want that transaction sent instead of sending it right away. And then we also have a full dApp that we built out for both scheduling a transaction and running a time node, and that's available at app.chronologic.network. Everything is live on Koban currently until we get the security audit back, and then the plan is to put it on the mainnet as soon as we're confident that the contracts are safe. So a little bit more about what the time node is. It's basically just a JavaScript script that can run both in Node and the browser. And what it does is it watches the alarm clock contracts. Every time a user schedules a transaction, it'll emit an event log, and the time node keeps track of these event logs. And it keeps track of when that transaction is set to be executed. So when that transaction is set to be executed, it'll basically send the initiation of that execution, which is just a transaction, to the smart contract. The function is called execute. And because that smart contract has all the parameters, it just sends out another transaction exactly how it's programmed by the scheduler. And then that time node will get the bounty that was given to that contract as a reward for executing this transaction. So the idea is that this creates a second layer market on top of Ethereum where it's both decentralized for anybody to run a time node, and it's incentivized by the bounty. So the hope and the idea is that you'll have many time nodes running, which will give you higher security guarantees than a single personal script. So we're super excited about that, but there are some open problems that we've run into. So one of these problems we've been calling transaction collisions, which means that the time nodes, since they're incentivized to execute transactions, they might try to execute over each other at the same time, and one of those transactions will fail and get reverted, which will cost that time node a small amount of Ether, some way. We have a miner front running, so it's kind of the same problem. A miner can also be running a time node, and through manipulation might be able to execute all the high bounty transactions. And then we have the problem that when a user schedules, they set the gas price that they want that transaction to be executed, but they can't, there's no way to tell what the state of the network might be when that transaction is executed, so the gas price might be something different. So to kind of tackle some of these problems that we have, we've been working on what we're calling the Chronos Protocol, which is kind of the alarm clock on steroids. And it's our test bed for a lot of experimentation. So what we're experimenting in the Chronos Protocol is conditional scheduling as well as temporal scheduling. So this would be something that would watch the state of contracts. And if the state of a contract changes, or if the state of a contract fulfills these conditions, it'll send out an execution. So to solve the transaction collision problem, we're revamping the claiming mechanism, which is the way that time nodes are able to just claim that they're going to execute a transaction when that transaction is supposed to be executed. We're experimenting with using tokens for this as a kind of staking or bonding mechanism. So a time node would put a bond that they're going to execute this transaction, and if they don't, they will lose that bond. And then we're experimenting with ways that this would be able to solve that transaction collision problem. We're also trying to optimize the gas cost as much as possible. So the current Ethereum alarm clock can be expensive because it does a lot of storage calls, because it keeps all of the parameters in storage. Basically, the solution for that is just to hash all of those parameters and check the hash when the execution is sent. And then since we're just storing the hash, we're basically sending all of the data as event logs. So we might use IPFS as like a storage backend, but we might not even need to use IPFS as long as the time nodes are all watching the event logs. And then we're really paying attention to plasma and state channel uses, because both of those projects need time-based executions for the exit mechanisms. And so one of the goals with Chronos is to make sure that it would be interoperable with second layer scaling solutions like Plasma or state channels. So all the code is open source. You can find it on our GitHub. There's a link down here. If you have any questions, feel free to talk to me or a member of our team outside. And also we have an active Gitter. So we have the Chronologic Gitter, and we also are active on the Ethereum alarm clock Gitter. So if you want to use the alarm clock to build on, we have tools at every layer of the stack, JavaScript, Solidity, and we have a dApp. So come talk to us there. Come check out our GitHub. Thank you very much.